Good morning, everyone, and welcome to another Athena talk, Learning and Entrepreneurial University talk. And we are very glad to have today with us a colleague coming from Greece, but he is now in Denmark, in Aarhus University, from the Department of Business Development and Technology. And the today's talk is very much related to the Athena Alliance, let's say, key priorities related to artificial intelligence and IoT. And yeah, we are very glad to have today with us Professor Michael Beliatis. A brief introduction about him, and then I will discuss also the title of his presentation. So, Professor Beliatis is an associate professor in AIoT. He will explain deeper to us about his specialization. At the Aarhus University, and he's also very much experienced on cutting edge topics such as the interface between solar cells, IoT, nanotechnology, artificial intelligence, mechatronics, smart buildings, digital manufacturing, and printing hybrid electronics, among others. And he is currently at the Herning campus in Aarhus University in Denmark. And he has obtained his PhD in laser processing nanoelectronics from the University of Surrey in the United Kingdom and the Advanced Technology Institute. And he also has obtained his master's degree in signal processing and telecommunication, as well as a bachelor in engineering in electrical and electronic engineering, both of them from the University of Newcastle, again in the UK. He has a lot of industrial experience besides his academic profile. He will explain to us in more detail. And he also is involved in many European and national projects related to the topics that he will explain to us today. And last of, but not least, he's also a senior IEEE member and IEEE Nordic Countries Nanotechnology Council chapter. About his presentation, the title is the following: Digital, Global, Smart and Sustainable Manufacturing, Business Model Innovation with AIoT, Robotics, Automation. So, Michalis, we are really glad to have you today with us, and we are looking forward to your presentation. Thank you very much.
Thank you, George, for the kind introduction and for the organization, everybody in the organization. So, thank you for giving me this opportunity. Yes, so the title is a bit long, but I hope you will understand later on based on why is that. Okay, so more or less this is the introduction which you gave about me. Yeah, a very wide background on different topics and based on the different things which we have done here, like some publications lately on different topics, IoT, business, and also interconnecting with materials and so on. Some of the previous projects, 3D printed, laser, printed electronics, energy monitoring and consumption, laser processing, and then I had also the opportunity to get involved with robotics and in business development from lab to actual commercialization with spin out company which was from the EU. And yeah, like we had the Kickstarter successful, like. Yeah, like also I have like established a research group called the Digital Global Smart and Sustainable Manufacturing. And yeah, like it's more like about we're looking about how digital smart technologies and sustainable engineering practices can support optimized business and process in industry manufacturing enterprises. So we are very much interconnected with local industry stakeholders to align the research agenda and yeah, like rigorously like. Some of the members from the group all the time they are changing. You are very welcome, everybody, to visit us. We are very open for collaborations, both scientific and more like industrial. Like so, you are very welcome. Also for exchange, if you want anything to send some exchange students, you're very welcome. Here's our small campus. As I say, we are in second, let's say the main campus is like in Aarhus City. We are in Herning, so we have a campus here, which is like in a very nice area. We have like some art also close to us. Some museum with shape of heart, and you see also in the nature that behind there we have some art. So just to put in the context, in the global perspective, like Aarhus, it's the main city where the campus is. We are located in Herning, which is like the head of the manufacturing in Denmark, let's say. So we have a lot of companies around us which support and support us. We have like a lot of nationalities in the campus. I would say like we have quite a few different courses from bachelor to master and to PhD also, and then some in the professional training uh, for life training. And we are around, let's say, like approximately 100, 1,500 students, 100 staff. And we have like the triangles education, research, and the common support so that's why also the research and education is like more or less focused on the needs of industry. Uh, if we want to see like the department structures, like we have the two divisions, which is like two sections, which is like one is the technology and one is the social science. So interconnects in the business, in the enterprise world, we see like we have the technology and the organization. As I say, we have like plenty of commons, and then which we support, and then we integrate them in our teaching. And so the idea here is that we have like several projects, semester projects, which the students we send them for projects inside the companies. They go there as a 3 months project. They work on solving something from the company, and then basically like they have to find the problem, what is the problem, and then formulate a kind of solution. So they get the opportunity to learn from what is really needed in companies and support also the companies with free hand, like let's say like. Um, for example, like in 2024, we had around 500 students like doing projects, educational projects, which they apply the theories from the lectures in the projects in a lot of different companies in the region. Some of the big names which I Lego, Grundfos, Kastrup, Vestas, Siemens. And typically we organize also for the master level some business technology, model innovation, which, as I say again, the whole chance at the master level is like they have to go in a company. The company have to come with a problem which has like both business and technology perspectives, and they work intensively like over 3 to 4 days to give some solution based both on mapping let's say the business and trying to improve the business operations with the technological solutions. A bit about the research and the teaching. We have also labs, and as a lot of we're dealing with a lot of companies, we want to see like as a kind of product development, and then how do they go into production. So this is like typically the enterprise level, how is a company working. So we have the physical world and also the digital world, which now is trying to connect with this digitalization called also like digital twins, servitization, different business models, and sustainability in the overall theme. So just to a bit more details, like you can see like in a typical organization, you can see like you have like different operations from planning the manufacturing, the old operations, design, specify like the whole production line, the product, build, and then validate, and then once you validate you manufacture, you have to ship it, like moving to the business part, you ship it to the customers, and then you see the whole life cycle of your transactions with funds and this kind of stuff. So inside there, we have a lot of your technologies which you need to support the operations from EOT, enterprise ERPs, scheduling, how to reduce the carbon footprint, circular economy to your reuse things, and so on. Also virtual reality, and these are more the topics like which we have here in the department. Uh, how we are doing our approach for research with companies, like typically we go in a company, we invite us for the problem. We do some kind of mapping of their capabilities, business capabilities and technological capabilities, like in terms of maturity and also sustainability. Then we develop some kind of solution, like at MVP demo, let's say like early stage. And then after some time, it takes time, we see how they evolve their business based around these changes which we propose. Like, yeah, and then we monitor the as is and to be, and we come up with improvements. There's a terminology called continuous improvement in manufacturing, lean manufacturing, let's say, lean methodology. Yeah, and as I say, like we have like a lot of labs. We started with a Digi Microfactory lab, which kind of resembles like a mini factory. But we have also other now labs developing material and data space compute. And the idea is like you have like the three themes: digital, green, and lean optimization to improve economically and ecologically the efficiency of business. And here you can see the map. Like we started like with the industrial revolution, industry 4, industry 3, long time ago, about lean manufacturing, then digitalization, industry 4, and now we talk about also green and sustainable manufacturing. Yeah. So an example, for example, how do we do the business modeling is like you can see, for example, for some similar cars, one made in Far East and one made in Europe, including the transportation, like the prices like from 2004, like they are almost let's say 100,000 difference, like which it is surprising how what is the business model, what is the capabilities, which they can support this. So you can see like for the one which come from Far East, like it's 10,000 lower price, including like 12 months of free energy, okay, for charging the car. So this is like the technology and the business model. How do they evolve together? Like how they integrate? Like how can you do this capabilities? Okay. In terms of industrial digitalization, circular economy, we see like how can we monitor different processes and how can they support the like based on data-driven decisions, like to improve operations. And our target sector is like typically like the commons which we have around in the region: wind industry, food industry, local industry, textile, and also we have some parts manufacturing commons who are doing automotive parts, like not full cars, like. For the labs, how do they we have different processes? So we have like frameworks which they're about lean, how to set up a production line, digital technologies like ERPs, PLMs, MES, SCADA, PLCs, EOT, 5G, 6G, cloud, edge also, and lately we were talking about also AI and machine learning. So how when you're collecting the data with EOT, you need to analyze them. You need to get optimization. Like so, there you use like machine learning and AI. And when you have like to collect also big data, like we call big data analytics again. And for the green point of view, like your CO2 footprint, we have this ESG, EPD reports now, carbon footprint, energy management in order to close loop the whole supply chain, let's say. And all those like for enhancing the circularity, the sustainability in business from economical and ecological. An example here, like from some lab, which the students they have to come inside, and then based on the framework which we teach them, they have to set up a mini manufacturing line using either simulations or like, and then implement it in real robotics in order to assemble something which they take from an ERP. So they get exposed to all the different technologies from networking, collecting data, programming robots, and then you're like down to dispatching for customers, and then creating kind of invoices for the cash flow to see like how is the whole operation is moving for the business to work. With that, I'll move to the next level. Like we have a new lab developing now, which you're like we are focusing a lot of in recycle, circular economy, and also like materials. Lately, we do also looking at materials like from hydrogen, and then how do you assembly like fuel cells like autonomously, and also connect them like for inspection and this kind of stuff with microscopy and the image inspection. So. And another thing, like is like another lab which we have. We have a computer lab which we do like all the data collection and also monitoring. So how do they connect all the different labs in oh sorry this one. You can see here, for example, like the if you want to see the operations from a company, okay, you have the design, as you say, like the different operations, training, monitoring. So like if you want to see like the material lab is like where you do the low TRL research for the actual materials, and then when you want to move to upcycling, like you go to the production line, how to set up upscaling the production line, and then dispatching all the operations. And then in order to collect all the data and analyze them, you need some kind of control room with a lot of computational power to do analysis of the data and digital twins and so on, like these technologies. So that's more or less the, let's say, like the how they interconnect the different labs. Like ongoing research projects. As I say, we are all the majority of the research projects which we have is like with involving companies. So, for example, here, like was a company who they're doing roll-to-roll printing for labels for food packaging. Yeah, and they're going to be able to monitor where is the errors in their printing, large-scale printing labels, and when they dispatch to the companies who they use the labels in their packaging, they can find where is exactly the error in the full roll-to-roll foil. So we implement some kind of methodology. We show like first like what is their maturity capability in digital technologies. We give them some let's say inspirational talks, and then we develop a framework with them, like and then an enterprise architecture involving like different technologies from IoT, ERPs, and then cloud, edge, how to connect the different data from different points and share it with their customers, let's say. Typically, another project, for example, is like we also um, give seminars and we test like what how they understand the different technologies, the companies. So how it's going to be, for example, here we had a seminar for a company which we involve in our labs. We give them some inspiration talks also with our students, and we test like like how they understand the different technologies, how it will be like the future work based on robotics, and what will happen with actual workers which they have like that. How can they retrain them like in order to cope with these changes? Uh, in also like like AI is the big elephant, let's say, in in the room these days. So how do you use like efficient like tools like ChatGPT and so on, like in order to progress efficient work efficiently in a high speed environment. In terms of AI and companies in, let's say, in industry. Construction is like always on you're like on needed. So both for industrial buildings, but also for commercial buildings. So here we develop a framework. How can you train and optimize like your the space, like the drawings, in order to have like the optimum operations. Here I'm showing an example from a house, but a similar way you can do also like with generative AI for shop floors, like how to where to put the different machines in order to optimize the efficiency of the operations. A big project which you like I say these days is like the sustainability, and we have like with circular economy for glass fiber. In the region here, we have like a lot of commerce which they use in glass fiber for wind turbine blades, boats, and also in the construction industry. So a lot of those materials, like when they are used, the scraps or the leftovers from some process, they are pretty good materials, but they end up in landfill, like because they don't use them. So how can we do something like to develop like further this like the reuse of these materials, okay, instead of just ending up in landfill? Can we do something like in order to improve the circularity and then some involve some kind of a business inside there? Okay, so we develop like the cost of circular economy for glass fiber. We look at it like in terms of uh, how can we reuse it, and then we for this stuff we develop a kind of database with different stakeholders, which they involved in the circular economy uh, in the Nordic region. So in order to be able to find the people which they can use like the scrap materials, you need to have also like like some kind of database which you can easily find the materials such like this. And yeah, it's accessible database, open. So we are hoping that we expand to the whole Europe. We have a new project, but we're also looking for open for collaborations. If anybody is interested for joining, you like in from an industry perspective, like if you want to join like the database, you are welcome to answer the questions, and then we will list you inside the database. So we have, for example, like in order to understand what we are looking, the whole circularity of the process, we need to understand that you have like a lot of different processes, value chain, let's say, all over the life cycle of the different from raw material until production and then recycling. In this project, we look like the production more like what to do with the scrap materials. And yeah, we had interview quite a lot of companies. We looked at have like a lot of cradle, close supply chain and industry ecology and performance ecology concepts in the things with it. So one of the cases, for example, here was like with the company. We got inside the company, we interviewed them. How they're doing business models now, like with scrap of material. We map the process flow, how it's happening, and where is the bottlenecks, what is needed in order to be able to reuse the materials. Okay, and then we propose a new business model, and we did some risk assessment in the new business model. Okay, so the idea here was like they have big rolls of glass fiber, which they have to roll it out. They have to inspect first visual like with a human if the quality of the material is good. And then they cut it in pieces which they needed. In this case for a blade. And we look also the costing in this case, like what is the cost for purchasing and waste handling in order to select the value cost benefit analysis, let's say. So we identify that the cost for handling the waste is like significantly lower compared to the cost for the whole operations. Like so, it's like around 1,000 euros per year, compared to like a full blade is like 1 million. Like so, that's why it's a bit difficult. Like let's say like to do circular economy in terms of costing. Like you're like what is the cost benefit analysis from there? Like, but nevertheless, that the waste from these commons they can be used for other purposes, which they can use small parts like to do other profit. So in this case, you need to have like kind of a very clean material, which other components they can use it like. And to do that, you need to do sorting. So identify where is we map the whole process, to identify where is the different process which is needed to do sorting, and then some life cycle analysis to see like what is the value generated from this process. We identify that the bottleneck is like in the sorting, and typical is like very cost expensive, like to have like a human there. So as a follow-up project, we develop for them proof of concept, like which we can use some AI, machine learning to inspect like the different scrap material and then sort them with a robot. So here, for example, is an example in a digital twin version. So the robot comes, he has some sensors. He can identify like with AI like the what is the material, and based on if it is like a scrap material with some contamination or not, he can sort it also. He can sort it also based on a different size. Like so, then you have like some kind of different materials which you can send it for different use to different customers based on the quality of the material. Okay, so here we develop the business, let's say, part is like the value which you create is like you can sort the material, and based on what is the material, you can create some extra value instead of just throwing in landfill. Yeah, uh, stuff like maybe yeah. Another project again on blockchain this time, like we have this manufacturing, let's say for the massive wind turbines. So a lot of components that have to be collected, assembled, and then once you assemble the wind turbines, you have to transport it in place, install it, operate it for 25 years, and this all 25 years you need to keep maintaining. Like so, a lot of stakeholders are involved, like from maintenance, from this kind of stuff, from maintenance and from operations. So you need to have a kind of traceability in the materials in order to see like what is need to change and what is the quality of the material which you take inside the things in order to have back traceability. So for this, we develop a kind of EOT solution integrated with blockchains using this kind of ranges and the QR codes to trace the different materials, and then also like when you are screwing bolts like in the wind turbine, what is the amount of force which you put there, like so you need to record that like for quality inspection. Yeah. So why is we use blockchain? Blockchain is good for it has immutability. So basically, because by default is designed so all the data they are recorded in different servers. So if somebody changes one server, you can trace it that you're like if there is a malfunction there or somebody on purpose changed the value. We have traceability, transparency. So this is like transparent to everybody, all stakeholders which they involved. It's a secure platform, so and it's a peer-to-peer also like. So basically, like it enhances like the operations in terms of like if somebody on purpose like you like wants to change something, we can trace it. So basically, like for insurance problems, like you like if for example there is a malfunction from a wind turbine, like wind turbine collapse, then you need to go back and check like the materials, like so that was why we use like blockchain and not some other technology like database, like. Okay. We developed the concept architecture, how to connect on site, like the materials, the different data collection points, the whole architecture from onshore and offshore wind turbines with IoT edge devices, collect them with using different IoT, different technologies like 5G, 6G, and then collect them in the blockchain network. And more or less, you can see like we have different data collection points, such like what is the QR code for the wind turbine, with the geolocation, QR code for the different components, then the different force which is used for screwing these bolts on the machine on the wind turbines. Uh, Early prototype about the different material data which you need to collect, and some low code programming with Node-RED, which is very common in IoT technologies nowadays. So another project, you're like following this, like how to once you collect these different technologies which you have in order to operate projects like that with which you collect data, you need to harmonize it also with different other like all the components like from different manufacturers, but also with different stakeholders like when you involve like service operators or other your stakeholders. They need to have like some kind of interoperability within the data which you collect, but also within the machineries. And for this, we develop a kind of standardized, like we use, like we develop, let's say, like a plugin which can modify the structure of different data formats, semantics, and this kind of stuff to the international data space standards at the EU level, so it can be harmonized and then be able to collect and understand the different data points from different stakeholders. Okay. From time to time, as you say, we have like a lot of comments who they're using robotic collaborative robots, and they have a lot of different, let's say, like tools which they use, and we see that from a lot of them, they're asking also why can we use like some kind of the robot as a multi-tool for manufacturing something, like because you can put a lot of different things. So in this case, we did a prototype of a 3D printer with a robot, which they can, develop like something as an extra tool, put on the robot, print something, and then change the robot, the tool, and assemble different things like, oh yeah, that was the idea behind here. And for quality inspection, different tools like at material level. On another project at EU level, here was like having developing an IoT Corolla search engine for Internet of Things. So identifying different IoT devices in the environment which you are and collecting data or understand what is the data which you have from different designs and then be able to use different selection of data in order to take decisions. So case study, we have one demo case study which we demonstrated this. It was like for room booking here in the university, which people, because we are you're like in the middle, we are a bit remote, let's say like campus. So people who are coming from different locations, they can identify remotely what is the availability of the rooms and what is the most comfortable room in terms of heating and stuff based on the data which we get from IoT sensors. Like okay, so we develop a kind of system there. Another example from a manufacturing company is like here we trying to interconnect digital and the physical tools in the internal supply chain of the company. So when you're moving parts from one department to another department, it's quite a big company in terms of quite big distances, like which you have to travel. How do you optimize this? This company was from have a kind of a better understanding of the work in progress in the full shop floor, like in the production line. So we map the assist case with a spaghetti diagram. And then we identify like what is their, we map them like the capabilities from digital capabilities in terms of understanding culture, like how people they feeling familiar to use these technologies, or you're like you need to be trained and so on. How do they accept the technologies? Um, and we identify also different technologies suitable for tracking metals, because metals they have like they are conductive, so they have special properties which sometimes they can hinder the signals from IoT sensors. So I identify suitable technologies like Sigfox and RFIDs, and collect the data. And here's a demo data board, which you can see like the work in progress, what is the status in the different batches inside the production line, like for the metal parts, like. And here is like kind of business model showing the whole supply chain of the solution, the new solution which we propose, like from device, connectivity, cloud, application service, and then the customer, how the customer is serviced based on this, and you create value for the company. Uh, I mentioned before that here was educations, like so we combine them with the research projects. So one of the different education which we have here inside the master level is the digital enterprise management education, which we go through a lot of like combination of business frameworks, and also how do you deal with process mapping, different technologies from IT, OT, IoT, Edge, AI, and then connecting the ERPs and the master data and so on, like again. And on those, we have to do a lot of different artifacts. We try to keep updated, like with what is used from the companies. So lately, we see like a big shift from, especially for the technical and programming programs, they use instead of programming, they go for low code programming. So a lot of things like Power Apps, Node-RED, Power BI, which and robot process applications, which you can set up automations like in collecting data and this kind of stuff without need to program in Python or Java and this kind of stuff. And yeah, we give them also a kind of understanding of the infrastructure, what kind of infrastructure they need in order to be able to interconnect all the different things. Like other things which we do also social activities. We have a maker festival every semester, every September. This time it's going to be on, I think, 11th, 12th of September. So we invite a lot of students, and we showcase the different projects which do with companies, so people they can understand what they're doing with companies and get intrigued and like join the campus, like the studies. Yeah, here's for example, like we have the tents with the different projects which develop. A lot of people around, and then they get to try also. Like for example, we have this kind of mini cars which they come, they race them, and then they understand like the concept of AI. How do you drive autonomous like inside the you're like in the lanes, like for racing. Uh, yeah. We have also like uh, startups, which they come out of these different projects when they identify some gaps in the industry which is need to be filled. So we have an incubator, which we do different projects. So some of those projects is like common successful companies, let's say, is Waste Hero, which they do sensors for EOT sensors for monitoring the waste in how much like the public let's say bins that are filled, so they can optimize the operation for emptying them. So you save a lot of they showcase that they can save a lot of from the public like communes for the transportation. Like instead of going around all the bins, they can only specifically target the bins with their full, like. And another example is like a common who they made a sensor for monitoring vibrations and then identifying like predictive maintenance, like for different motors which they're about to fail. What is their health like? Yeah. With that, more on the academic part, like as we have this materials lab, which we do also like collaborations, and we have a special issue we developed with some colleagues on AI for materials design and process from manufacturing and also for products. So we are welcome everybody who is interested to publish something. You can send us something. We're very happy to welcome you. And with that, I would like to thank everybody and conclude my talk for today. I hope I'm on the time. Like,
Perfectly on time, Michael, and we are really, at least from my side, I'm really glad to see, connection between university and industry, and to give, the direct opportunity to the students to get involved. So I believe this is a very nice, uh, like. Approach you have as a university, and I think we will be really glad to to work together with you and your university in order to exchange ideas and promote this kind of approach in the Greek system as well.
yeah,
Now I
sure.
would like to give the floor to uh, anyone would like to ask any question. So maybe Michael, stop the share screening and we
Yeah,
start
I'll stop this.
the discussion. I see.
Mhm,
I will give the floor first to my colleague, Professor George Kavoulakis.
mhm.
Well, first of all, I was really impressed with your presentation. Uh, but I have a very naive question. You presented to us all kinds of different problems which require knowledge from different fields.
Mhm, mhm.
I mean, have you hired people from different fields who help you, or because it seems to be
Yes,
very hard
yes,
to cope with
yes.
all these different
Yes,
problems, right?
yes, yes, yes. I can explain that. Like we have, that's what is happening here. Like as I say, we work close with companies. So in the company environment, you have like a lot of different fields. Like so, typically, we have people who they come on the field, which is like their expertise. But once they get hired here, we get involved with a lot of different projects. So we develop their skills like to be multidisciplinary, interdisciplinary, and that's why we have also like the both. You can see like at the very beginning, I said like we have the technology and also the social science. So you can see both the business perspective and we have similar. We have joint seminars, joint projects which we involve, and then we co-develop like so it is good from society point of view, but I can understand like that we are very broad like but also the level of the project which we are working is at the high TRL, which is like more close to the companies. I understand like you're like going down to a field like which is like more narrow to materials. You're like it will be very focused like, but the point is like that can you use different technologies, different fields like to support this companies? Because what the companies are doing is like at the end like they use all these different things in order to have the operation, the business running. Like yeah, so that's our approach. Like it's kind of mixing everybody and race from there.
Very nice. Thank you.
Mhm.
Thank you, George, for the question and Michael for the reply. And then I see also a hand raised from Shmuel. Yes, please.
Yeah, thank you very much on very interesting presentation. And I want to ask you how, according to your opinion, integration smart and sustainable digital technologies in business can support resolution problems of poverty and improvement social and economic well-being.
Yeah, I think it's very important, like to be short answer, like okay, because everything interconnects at the end, like okay. So the more you're like you optimize the process with digital technologies, you help like people, like for example, like instead of having a person like dealing with inspection for glass fiber, which is like it can be irritating for the skin. You develop a kind of system with a robot, a machine vision, different technologies, and then you have a person to work more comfortable, like yeah, like instead of being in a harsh environment. So that's the point that yeah, it's very crucial to have this kind of development because the technology exists. How do you use the technologies in order to improve the work environment and the social, like benefit for the workers and you can see that also later on in the business, like like they are more happy the people, and they can support the company more happily, like like instead of leaving to another company, they stay there because they're happy to work. Like.
Thank you, Shmuel, for the question and Michael for the answer. And then is there another question from the audience?
Yes, George, may I ask something?
Yes, Apostolos, yes.
Michael, very nice and interesting presentation. Lots of insights on how the AI can bring things from different perspectives. My question is more related about your newly established recycling activity for raw materials. So, as far as I understood, you using AI. Will you use or implement AI in order to improve or train AI to give much more valuable insights regarding the levelized cost of efficiency or the waste management on the landscape of those materials, of the green technologies such as the batteries or solar cells? Because electrical, for example, is one of the things that's highly used in societies at the moment. It's a trend. Have you found any relationship, any improvement that the AI could revelize those insights in order to improve the activities of the green technologies?
Yeah, I think this is like going down to knowledge of the domain. Like, so for example, the specific companies, like the specific industry, like, so we don't have too much solar industry here, like it's more like wind industry. But I'm pretty sure, like I have seen, like some companies who they're dealing with at different levels with AI for solar. For example, in the operations of the solar farms, like they have like digital twins, and then like how they map like the model of the source, and then you can predict if the solar cell is going to operate well or if it needs to be replaced, and so on also. And then for waste, always there are. It depends on the topic. Like I'm not. I don't have some case like from solar industry. Like to be honest, like yeah.
Thank you very much, Michael.
You're welcome.
Thank you, Apostolos, for the question and Michael for the response. And let me have a look on the chat. I don't see. I have a question, actually, Michael. Also, thanks again for the insightful presentation. But what it comes to my mind, of course, I understand, involving such technologies can definitely, let's say, from one side, help, I mean, the environment regarding sustainable production of materials or a sustainable process. But on the other hand, I think and I believe, I mean, both AI and IoT are carbon footprint intensive technologies. So at the end of the day, what dictates if a process or a development of material, I mean, in a small medium enterprise where the production is not so high, is this approach beneficial, and how beneficial at the end of the day do you have a model or a process to measure this benefit?
Yeah, we have seen some stuff like with this case study which I had for the construction industry, like with the floor plans, like and the same approach. Now we are looking also to do some kind of use generative AI for creating new materials, which they are synthesizing new materials, which at the like digital level, which can be the process to synthesize them can be less energy consuming. Like now, on the computing, process like energy which is required from the computers. We have seen that like a lot of those projects which we have is like typically running in very good also in computers which are like made for gaming, let's say, industry. Like so, they are not super high servers which they need like extremely energy. Okay, like having said that, their energy they need the energy computational high, but our so far approach is what we use like mainly with low cost computational units, which like it's the same like using your computer like your normal laptop like that like and one is that like other thing is like that every country they have like also national centers for AI. I know both here in Denmark and also in Greece there are something where they have national center for AI, which there they develop like servers with very high capabilities, which is like centralized, so they can control also from there like the computational power. If you need, you have access, you get access like for high computational power, and also somehow they control the energy. And if you design correct, I believe you can utilize the excess energy from, for example, when you have like wind industry, wind, a lot of wind, which you don't need the energy in the grid. You can store it somewhere and utilize for powering up systems like that, which they need a lot of energy. But yeah, I don't think so. It's like that bad as it is in the media. Yeah.
Okay, thank you very much for the response. We have time for one last question.
George, may I ask something else?
Yes, please.
Regarding the security concerns of the IoT,
Mhm.
what is your insight, or so far, what are the findings behind of your research or your activity in this field?
Cybersecurity and resilience is a very big topic nowadays. Okay? It's like, so it's very important. And you look also like when you talk about IoT field before 10 years and IoT now, there are a lot of improvements like in this area. Like how do you both like encryption, but also like physical. How do you make sure that they will work resilient? How you make sure that it's not hijacked? So there is a lot of effort. There are a lot of projects we involved in cybersecurity projects for us primarily to inform industry like good practices. So one very important thing is like okay, one is like the at the technology point, like how to have, which is like continuous develop. So there we cannot do too many things. The second thing is like to inform like the users to use the best practices. Like so, how do you use like encryption? Use your like the password only for your work, not for anything else. Like when you're going outside. So these are our like a role here, like in the industry also, how to give them, train them how to use the best practices in order to ensure that they have some resilience in operations from cybersecurity point of view.
Thank you.
Thank you, Apostolos, for the question and Michael for the reply. And yeah, I think if we don't have an additional point or question, I would like to thank you, Michael, once again for your contribution. This is very inspirational, the approach of your research group and in general the activities at your department and university, and we'll be very glad to establish some formal connection with you and the university to learn, if possible, things related to on how to connect our university with industries. Thanks once again, Michael, and
Thank you from my
for
side
the rest
also.
of the people, we will continue, of course, after the Easter break. So, Καλό Pascha, happy Easter to everybody, and
Happy Easter, yes. Thank you
talk
so
to
much for
you
the
in
invitation
another
from my
Athena
side
talk.
also, and you're very welcome. Like you continue your like further collaborations and so on. Like
Thanks a
Thank
lot.
you.
so. Thanks a lot, everybody. Have a nice Easter.
Take care. Bye.
Bye-bye.
Bye
Thank you.
bye.
Bye-bye.